Welcome to Chapter 3 and the Payment Management System course. This chapter we're going to deal with Payment Management System development as well as implementation. So the way PMS is really managed are by two different personnel, management personnel as well as technical personnel. The management personnel are really concerned about public relations, government operations, as well as politically acceptable decisions. In fact, also whenever we come up with bigger decisions, we need to come up with a good usage of simple layman term in communicating with the government leaders and with the public. You need to keep everyone happy about what you have done in the payment network. While you, being as an engineer, you will be concentrating more into the technical personnel, which is concerned with actual engineering data and how can we deal with the performance of the payment. So before even we start thinking of the PMS implementation, we need to develop and implement PMS management. We should identify the following points. The very first one is, how can I identify performance standards? So there are several standards, for example, the ASHTO standards or the ASTM standards. So before I start implementing any PMS system, I need to know and identify what are the standards that I'm going to use. Simply because if I change the people that they are measuring the data or the engineers, or every time we can go back to that reference, to that standard and use it and be consistent. Same thing for budget planning policies as well as budget distribution policies. How can I come up with a standard or a practice that can guide me through the budgeting, planning, and distribution? If I have certain amount of dollar amount every year, how can I spend it wisely and keep the health system the same? If you remember from the previous chapters, you could have the same amount of money and you can spend it mainly on couple major reconstruction streets, and the entire remaining network streets are gonna suffer from payment distresses. Or you can spend that money in a wiser way that you can spend it all over the network with minimal amount of maintenance and rehabilitation, and you would eventually keep the health of the network at a high standard. Also, you need to keep in mind some social and environmental issues. If we are dealing with different techniques or different materials, sometimes the smell, sometimes the health of the crew would be an issue. So you need to be aware how can you be ready to respond to any social and environmental concerns from the neighborhood. Also, you need to identify the size of the payment management system. PMS can be an individual unit, such as the Texas DOT, or it can be only just planning division, maintenance division, or even materials division. So it depends on the state highway agency. Sometimes we would have all these three divisions as one unit, or they can have three different units together. And really the main goal here is that the three divisions has to talk to each other, and there should be a good communications between the three of them together to have practical and implementable PMS system. So what are the major steps that we need to follow to develop and implement a PMS system? The very first one is really we need to decide if the PMS is needed. So that's something to keep in mind. We need to show that it has its benefits. The second step would be obtain the agency support. Third step would be organizational analysis. The fourth step is developing and selecting a certain PMS system. And then this is going to be followed by implementing the PMS system as well as obtaining effective PMS operation. The very first step in implementing PMS systems is to decide if PMS is really needed or not. So state highway agencies, or SHA, I'm going to use this term quite extensively, that they have no option whether to develop or not to develop a PMS. in the last 10 or 20 years, we have shown through historical data that the PMS is a must, and now it became a requirement in every state highway agency to have a payment management system available to run and maintain the payment network. So the reason for me here to include that step number 1 is these steps can be really used in some other countries. If you end up going overseas and there is now a chance to start implementing such system in other countries, then the very first step is how to convince the managerial level of the need of having PMS system. So, as I mentioned, outside the U.S. statewide highway agencies and the rest of the world, we need to recognize the need. Why do we need it? Is it gonna save us money? Is it gonna keep and maintain the network health in a good condition? We need to obtain a good PMS knowledge. You will be mainly the only engineer or one of the fewest ones who have a good understanding of the payment management system and how can you run it and how can you maintain it and implement it. So that knowledge needs to be transferred to other engineers and technicians. We need to decide to implement the PMS system, as well as developing aliases, and eventually we need to get the PMS into the agenda. So many times we have meetings and even sometimes conferences. Your job as an engineer to bring this topic, the PMS topic, into the agenda and to the conferences to let others understand the benefit of implementing such system. Step number 2 now is to obtain the agency support. So top management must make that commitment to support the development of PMS. They have to give the green light more or less to the technical staff, including engineers and technicians, that they are having their full commitment that they will support the implementation of a payment management system. All state highway agencies units must understand where PMS fits within the system. Therefore, the way to obtain the agency support, first of all, you have to persuade the agency. Then the agency would end up deciding to implement the PMS system. Afterwards, you have to have a good steering committee. That steering committee is going to be able to push the idea forward to practice. After that, we need to get funding commitment. That amount of funding is going to be spent mainly in 3 different components. First of all, we have to have skilled personnel, engineers as well as technicians who are well trained and knowledgeable of the PMS system, the benefits, how to implement it, how to go to the field and do the field measurements and observations. Also, the funding commitment would cover field equipments. Back in the days, we used to do lots of measurements in the field manually. Now we have several automated systems that need to be bought and included in the budget to be used eventually in collecting data. And lastly, but not the least, is the office equipment. Now, once you collect all the data from the field, you need to have a very powerful computers or some softwares that can process the data, which is going to help us, the engineers, to analyze the data in the best way possible. After we get the funding commitment, now we would need to form implementation group, including managers, engineers, technicians, as well as developing and selecting and even testing the PMS and see what's the benefit of using it. So the definition of a steering committee is basically it's a committee mainly including engineers as well as top managers to provide guidance and direction to implementing such system, as well as providing time frame for state highway agency policies. Again, you need to make sure that managers are included so you would eliminate any political problems that can rise in the future. So the steering committee, one of the major objectives for having it is to provide solutions for several aspects into the payment management system. The very first one is They need to give us feedback into evaluating current practices. Sometimes our local state highway agency would look into the literature review and would look at nearby state highway agencies and try to see if all the other practices that have been used is applicable to us. Then we need to identify, based on this, some additional needs. We may need some to collect more data in certain aspects compared to the other. For example, if there is a city or a state that deals with high amounts of rutting because of high temperature, for example like Phoenix, Arizona, then we would deal with more of rutting problem more than others. Then we would concentrate on collecting more accurate data regarding rutting, compared to a place which is a cold weather, which has a cold weather. Now the difference between daytime and nighttime temperature is going to generate thermal cracking more than any other distress. Then we have to identify that yes, we need to collect more data and more parameters related to thermal cracking. Also, we need to identify the data requirements. How much data do we need to collect, and what the amount of details that we need to obtain. Step number 3 is now organizational analysis. We need to now to come up with developing and selecting and designing payment management system. We need to keep in mind how can we come up with a process to modify payment management system. So many times, even among engineers, we think PMS is a fixed system and it's not going to be modified in the future, but that's not true, and we need to come up with a process to modify it. We also need to prepare an implementation plan under this step, as well as running a trial implementation. Sometimes we tend to think that we need to collect all the required data for 5 to 10 years before we run a payment management system analysis, and that's not right. Basically, we need to come up with a trial implementation. Even if you measure data for 1 or 2 years, you can collect these sample data and use some other default analysis values to run initial trial to see the prediction and if we're going to the right directions or not. And eventually we need to document those results and see if they are applicable to the true payment conditions or not. Under step number 3, we need to appoint a PMS staff. So we need to have a lead PMS engineer, and that's probably going to be you, who need to manage, coordinate, and operate the payment management system. You should be able to have a good amount of authority to make decisions and accomplish tasks. Otherwise, again, things are going to take much longer time if you want to go every time to the managerial level to come up with a decision or to accomplish certain tasks. You should also have a good connection with various divisions within the state highway agency. As I said before, you may have different units within the state highway agency, and every one of these units are gonna act separately, but you need to keep in mind to have a good implementable payment management system. All these units, including maintenance, materials units, has to interact pretty significantly with each other. The system development or selection, we need really now to come up with development and selecting and modifying the PMS in order to meet the objectives set forth for steering committee. Therefore, we need really to establish and estimate the cost that is going to be required to develop, implement, and operate the system. And eventually also we need to collect information regarding the cost of the equipments, which is going to allow us to select the appropriate equipments and the methodology for conducting payment surveys. In addition, one of the most important factor that you need to keep in mind while you are organizing the payment management system is how much the data that you collected are accessible. So the accessibility of the data, as well as communication and flexibility of the system, is very needed, and you need to keep that in mind while you are implementing any PMS system. In fact, there are 3 basic requirements that you have to maintain a practical PMS system. First of all, you have to have good data. And when I say good data, it has to be precise as well as accurate data. Also, you have to have a good analysis. So you may have the best data in the world, but if you cannot do and perform good analysis based on it, then it won't mean anything. Or vice versa. You can have the best analyzer, but we did not spend a good amount of time to select and observe and measure an accurate and precise data, then the analysis is not going to lead you anywhere. The other aspect is also an effective communication strategy. I'm going to go back again and say you may have the best data analysis and the most accurate data, but if you are not communicating the results with others in a good and efficient way, it won't be of any use. So you need to keep those three requirements in mind. PMS management system really should be considered as a dynamic system. So many engineers, again, they would think that the PMS, once we build it, it's gonna be one rigid system and it should not change over time, and that's not true. We need to keep building the PMS management system incrementally or in phases using modular approach. And the golden rule, always, you need to keep the data as well as the entire system as simple as possible. Step number 4 now would be selecting certain payment management system. Under step number 4, we need to review the goals of implementing such system. We need to review the implementation plan as well as the commitment to implement the system. Step number 5 would be now implementing a payment management system. In order to do so, first of all, you need to train your staff. As an engineer, after taking this class, you will be having a good amount of knowledge to run and implement payment management system, but you are not enough. You should have an entire staff trained with you to maintain and implement such system. Also, you need to collect an accurate and enough amount of data to run the system. A payment management system by itself cannot be used if I do not have a good collected amount of data. And above all, you need also to complete all the modifications that's gonna come up over time. Under the same step, which is implementing the payment management system, we need to demonstrate on a small scale and fine-tune as needed. As I said before, we have to try the payment management system even with the least amount of data available. And the next step would be debugging the data collection as well as the analysis system. So the only way really to debug the data collection is to keep trying and do a small scale analysis before we fully commit to that system. Step number 6 now would be operating the payment management system effectively. So people are really the most resource of the operation of payment management system. Therefore, you have to make sure, as I mentioned before, that the personnel must be trained, qualified, and very experienced and dedicated to the success of implementing such system. Step number 7, which again I didn't mention at the beginning because it's not an official step here, is really a follow-up. So the system should be reviewed periodically. We need to make sure every few years that the system is running according to the original plan. If there is any feedback that we are getting from the managerial level or from the neighborhood, we need to keep that in mind because it's very essential for the long run success of the payment management system, which is going to eventually maximize the benefit from it. PMS should also be flexible to allow future modifications and improvements. It should not be that rigid that's not going to allow us in the future to change it. We should keep in mind from day one that whatever we start with, it has to be flexible enough to change based on the feedback that we get in the future. The question here would be, what are the major changes that may happen based on the follow-up process? So those changes can affect the database requirements. Sometimes again we need to measure more detailed information regarding severity and extent, or for some distresses that we do not see very frequently, we should not collect more detailed data about it, or vice versa. Also, the changes can affect the prediction models, and this is really one of the biggest changes that we typically see. For example, for the first 5 years or so, we're gonna come up with a prediction model, and then by time, now we're gonna collect more data, and now we need to come back and readjust this predictive model to have more accurate predictions. The changes also may affect the economical analysis, as well as affecting the type of reports. Sometimes the way we report the data can be changed from one year to the other year. While minor changes can include enhancements that simplify and streamline the process. The remaining question under step number 7 would be, what is the right timing and frequency of applying such changes? So when it comes to major changes, typically we consider those changes every 5 years. Otherwise, again, it's going to be a very difficult process to do a major changes every year. But when it comes to minor changes, we should keep doing them as often as needed. So the question here would come is, what's really the main objective of highway agency? And the objective really is to provide a network for serviceable and safe pavements, and the goal is really to do that at a minimum cost for both the agency and the road users. So the tool to accomplish this objective is really the PMS. So the payment management system, which really can assist in making decisions, and also can identify cost-effective strategies to provide a serviceable as well as safe payment system. So the question here is, when we are dealing with a payment management system, we are dealing with an entire payment network. So the payment is really a complex structure. We need to be very aware of the material characterization. For example, what's the modulus of the hot mix asphalt? What's the strength of the base and sub-base materials? We need to know that. Also, we need to be aware of the very variable pavement performance. Sometimes pavement perform very well in some location, and the same exact mix would be performing very poorly in another location. Also, the pavement has variable loading conditions. So, for example, if we pick on some local streets, the AADT would be very low, which is the average annual daily traffic, versus other streets would have a very high traffic amounts, and this is definitely gonna generate different amounts of distresses over time, and pavements tend to fail at higher traffic much more than pavements that's dealing with less amount of traffic. We're gonna be also dealing with variable soil support. Sometimes you would see that the California bearing ratio for some soils is 5 or 7, so it's very low value, and it's not gonna provide that much of structural support to the layers above it, while there are other soils that they are very strong and they can have that amount of support. Same thing for the variable environment. Hot weather versus cold weather, freezing weather versus dry weather, that's gonna affect the pavement performance and eventually the entire network. So the solution here, or in fact more of an approach, is basically to come up with systems engineer approach become now very attractive, simply because it uses physical observations or measurements to characterize the behavior. Basically, I'm gonna send technicians to go to the field, observe the sections, and observe the distresses that we see in the field. Then it uses theoretical models to predict the response. As we mentioned before, our goal is really to keep measuring information, measuring distresses, that is going to allow us in the future to predict the future performance. And eventually we're going to model the responses as required and as adjusted based on field observations. So, which is again a continuous process that we'll keep doing over and over under the PMS system. So the question here is, when it comes to the network level PMS, the entire highway system is really referred as a network. So when you hear some definitions as a network level versus project level, like what we discussed in the previous chapters, the network is indicating that the entire highway agency is covered under that name. So the question would be, what are the major objectives for the network level PMS database? The very first one would be establishing a network budget requirements. We need to know again what are the budget constraints that we have, what's the budget requirement for every solution that we can apply to the pavement. Also, we need to know how to allocate the funds according to the priorities and scheduling of maintenance, rehabilitation, and reconstruction actions. Sometimes again we may have the same amount of money, but assigning it into different scenarios of rehabilitation or maintenance will affect the amount of allocated funds. So to achieve these objectives, network PMS must really have several components. The very first and foremost important are the information. Those information concerning the current condition of the pavement network, as well as PMS database. Once you have all the information required to run the database, now you need to establish, as I said before, you need to establish maintenance, rehabilitation, and reconstruction policies. More or less like a matrix decision or a tree decision. In case if you go to the field and you see one or two or three different types of distresses, you need to come up with a policy that's gonna lead you to the right decision, either again minimal maintenance or rehabilitation or all the way to reconstruction. Also, to achieve the objective of the network PMS level, we need to estimate the available budget. How much is gonna cost us to keep the network health in its current condition, or even how can we improve it. We need to know how much it's going to cost us. And all the way to the network priorities. We need to put priorities, which street or which group of streets at the network are the most important compared to less important streets. So here I'm just giving you some examples of network systems for various entities. For example, state agency can cover interstate highways like I-20 or US routes like 366, or all the way down to state routes like Texas US 66. Here is another example of an interstate that can be treated as a full network. Here is Interstate 90, which is the longest interstate highway in the United States. As you could see, it goes from the furthest west part of the country all the way to the east. So again, that interstate, it has about 3,100 miles, and it can be treated as one full network by itself. Another example here is the US Route 66. As you can see, it really goes from California, Los Angeles, California, all the way to Chicago, Illinois, and it goes through several states. And again, this can be treated as one network by itself. When it comes to now the state of Texas highways, we have, as you could see in this picture here, this is Tyler, and the highway that goes nearby to Tyler is actually I-20, that goes all the way to Dallas, and then it continues until it reach this intersection here with I-10, and then it goes all the way to El Paso. Same thing, there is I-35 that goes from Dallas through Waco all the way to San Antonio, all the way to the ocean. Another highway here, we have I-37 that goes from San Antonio all the way to the east part of the ocean. Now we also have a little segment of I-40 at the far north of the state of Texas, and again that's a major interstate. So as you can see, the entire state can be treated as a network, but we will find out that it's not really practical to treat all those networks or to treat all these streets as one network. So typically we would subdivide those into sub-networks, if you will. So another types of network systems, it can be the airports. So airport authorities are gonna deal typically with runways, taxiways, and parking areas. Those are the three major pavement surfaces that we would deal with as an airport facility, and each one of those three elements are going to be treated differently, from the budgeting all the way to designing and coming up with maintenance rehabilitation techniques. Here is our local network. When it comes to airports, this is Tyler Pounds Regional Airport. As you could see, we have parking area for long-term parking, we have a short-term parking, we have the terminal area, and also we have rental car or drop-off and pickup. Same thing here, where we have right-of-way zone, and eventually we would have the runways somewhere here. So again, each one of those areas are going to be treated differently when it comes to rehabilitation and maintenance techniques. This is here now the airport runway and taxiway. So as you could see, we got two major runways, one that goes in this direction and the other one is going that direction. These are the runways, taxiways, as you could see, 1, 2, 3, 4. So those are the little ones here that they are going to be treated as a taxiway. And this is, as I showed you on the previous slide, this is the airport facility, including parking spots as well as the terminal. So again, I want to stress on the fact that each one of these three components, parking areas here, runways, and some of the taxiways, are going to be treated differently. Also, when it comes to PMS networks, it can be treated from the perspective of a city, county, or even municipality. So we may have local streets, major streets, all the way to parking areas. And as I said before, they are going to be treated. Even sometimes when we talk about a private network, the network can be private when it comes to parking areas. So if there is a big parking lot, it's run by a certain private company, and they would like to keep it in the best health possible, then they would again go through minimal amounts of PMS database to keep the parking area in the best case scenario, so it would attract more customers. So when it comes again to now managing the network level PMS, we really need to look for what we call data needs. What are the data that we need to collect to run the payment management system? The very first thing is we need to collect inventory data. So when I say inventory data, it really consists of the permanent features of the pavement. Sometimes this is going to be including the width of the street, what's the how many lanes do we have medians, we do not have medians, do we have shoulders, we do not have shoulders, some of the physical components that really doesn't change that frequent in the roadway. And that's why it's really obtained once, because things like this doesn't change overnight. It really takes a longer time to change, but once that change happens, for example, as you could see when you drive through the Dallas area, you would see a lane is added, or the width of the lane sometimes changes to handle more numbers of lanes. If that's the case, then you would have to have update the system as required only when those changes occur. So the inventory data also has to provide overall picture of the entire network. For example, you should ask yourself how many miles of flexible pavements. Now again, looking in from the network perspective, let's say the city of Tyler as a full network, you need to know how many miles of the entire network is paved with flexible pavements. And when I say flexible pavements, it's the black surfacing with hot mix asphalt. We also need to know how many miles of rigid pavements, how many miles of urban pavements, and even how many miles of rural pavements. So the first two can be treated as one group. So how many flexible pavements versus rigid pavements? For example, let's say from the US network point of view, it's about 95% of flexible pavements and 5% of rigid pavements. The other type of classification in the network would be how many miles of urban pavements versus rural pavements. Still also under the inventory data, we need to have typical information regarding the route number. As we can see in any PMS database, it has to have, for example, a route number or a route ID. What's the functional classification of that road? Is it an interstate? Is it a local street? Is it a collector, arterial? We need to know that. Also, we need to know the length of that street or that section. On top of this, we will have to know what's the pavement type and if there is a shoulder or not. Some information also regarding the geometrics you have to collect, like the number of lanes as well as the lane width. We need to know the layer thickness and material type, this is really one of the most important factors, which is again the layer thickness and material type. Very important. How many layers do we have, which is going to govern the overall performance and observation of the pavement. And lastly but not the least is also you need to be aware of the climatic factors. We need to collect all the required information regarding temperature, precipitation, and whether we are having a freeze and thaw cycles at that location or not. The question here will come, how about traffic data? So traffic data is not really considered as an inventory data simply because it changes every year or every other year. So although traffic volumes are used in inventory data to classify and subdivide road sections. So you may see that there are some traffic information in some PMS databases, but those are used mainly to divide and classify the roads. But traffic is treated differently and it's stored in different databases. So one more time, if you see traffic data like average annual daily truck traffic, this is going to be used just to classify the roads. Do we have local streets, collectors, arterials, or interstates? This is going to be based on the amount of traffic. The other thing that we need to keep in mind when it comes to collecting inventory data is we need to use standard data collection forms in order to maintain consistency. Sometimes we would use certain form for several years and then we will change it, or a technician will come up with his own or her own way of collecting the data, and that's gonna make a problem in collecting a consistent amount of data. So we need to keep in mind as a PMS engineer is to keep the way we collect the data very consistent. Otherwise, the precision and the accuracy of the data are gonna be compromised. Majority of the inventory data should be actually available in the historical records and contracts. Every time you try to collect more data regarding inventory data, you have to go back to the old reports, and most of the reports at the very first page or so, it will include some general information regarding the historical record of that street, and you can use this information to fill the inventory data in the PMS system. And the question now is, how about if I try to collect this data and the data are missing? then the only solution that you would have is to have a field investigation, which is really can be used to back up some of the data, such as material types and layer thicknesses. In so many cases I have seen that we are missing the history of the layer thicknesses. So we are not sure how many layers do we have, what's the thicknesses of each layer. So we have to go back to the field and do some non-destructive testing like ultrasonic testing to know the thickness based on the different density of each layer, or we would just go to the field and take a core, and that core is going to go all the way to the soil layer, and it's going to tell us exactly visually how many layers do I have and what's the thickness of each one of those layers. I think I already mentioned this, that the data must be in a uniform and standard units. So the units also is part of the consistency. Sometimes you might follow the same exact standards, but you are using different units. And in so many cases I have seen, whenever we plot sometimes fatigue cracking versus time, sometimes we would use square meters and sometimes we would use square feet. So, and this gonna make inconsistent observation, and that's why before you proceed you have to make sure that the data unit system is consistent. So the original data must be stored along with any conversion factors used. For example, again, if there is any conversion to change the units from square meter to percentage, and you will see this, for example, in the LTPP database, that the fatigue cracking is stored as a percentage of the entire area of the section, while sometimes if we send the technician, he or she will send the information back including square meter or square feet. So we need to include what was the conversion process that we used to convert those areas into a percentage. So once we're done with the inventory data, now I need to identify the pavement sections. So after we collect all the inventory, now how can we subdivide the network? Again, the network will consist, for example, as city of Tyler, still lots of streets, and we can't treat it as one single unit. We have to subdivide that network. So the subdivision really depends on the type of the network, either if it's roads, including highways and streets, or parking lots, or airfields. So network can really be defined by branches or sections. You have to divide your network into subsections or branches. So the branch is typically readily identifiable part of the network, such as a given street or runway. Some of the examples of branches can be, a branch can be a one single highway, or one single long street, or certain parking lot, or a runway. For example, again, when we discuss the example of the Tyler Pounds Airport, we have couple runways. Those two couple runways, they can be treated as a branch by themselves. And the way we identify those, we would use existing names to identify such branches. So because branches are typically large units which do not have consistent characteristics, they have to be divided into smaller components called sections or segments. So those subdivision of networks in branches and sections are really done for management purposes. Again, if you have a big network, you can't really process that much of data and control the full amount of streets underneath the network, and that's one of the major reasons for us to come up with segments or sections. Otherwise, managing the entire network as one entity would be very impractical. So here the question would be, what are the other factors that I can use and consider while I'm subdividing the network into PMS sections? The very first factor is the pavement type. So assume you have Tyler as a full network. I can subdivide the network into flexible pavements versus rigid pavements. This is going to be a very initial and very important type of subdividing those two different types of pavements. Then the second level would be the pavement structure. For example, the layer types or the thickness. So among the flexible pavements, I may have a group of streets that they have 4 inches overlay, and other streets that they have 6 inches, and others has maybe 8 inches. So this is one of the ways to subdivide the sections into thick, medium, or thin sections. I also can subdivide my network based on the functional classifications, either interstate route, US routes, either is it a major road or local road. This also can give me a chance to subdivide my network into few PMS sections. Also the area classification, is it an urban versus rural areas? That also can be a good factor to be considered in subdividing the network. Also divided highways should have separate sections for each direction. So for example, again, I'm gonna pick on I-20. It's a divided highway, so we can treat the eastbound as one section and the westbound as another section, since they are totally different, and sometimes even the amount of traffic on both sides are different, so you can treat them as separate sections. Going back to the airfield pavements, when it comes to airfield pavements, especially at bigger airfields like Dallas-Fort Worth, you can section even the runways and the taxiways based on the amount of traffic that they are dealing with. So you would see that there are little airplanes that they would use certain runway versus the more wider and thicker pavement layers for the runway and the taxiways for bigger airplanes. So I can divide even the airfield pavements based on the amount of traffic that they are dealing with. How about one of the questions that always comes out is, how about the intersections? Let's say I have 2 streets that they are intersecting, and the 2 streets, it happens to be one of them is local and one of them is arterial or collector. So they are totally different in classification, and we decided to treat them under different PMS sections. And the question is, how about the intersection between the local and the collector street? How should we treat it? So intersections in this case should be included in the heavier volume streets. This is here an example of network level PMS. So as you could see, we may have an urban rigid, rural rigid, and then we come closer to the intersection, and now we have flexible pavements as well, and flexible pavement. So the way now we section this highway is, first of all, we have rigid versus flexible pavements. So that would be the level 1 of sectioning the network. Then we're gonna come back to the rigid section and see that the first maybe 10 or 20 miles were urban, and then now we're driving through a rural area. So this is also a good reason now to subdivide the rigid section into 2 sections, urban and rural. Now when it comes to flexible, if there is no change, then we can keep it the same, or also we can change it based on other factors. How about this ramp here? This ramp brings high volume traffic, so it's gonna have another consideration that this section here is gonna deal with a lot of traffic compared to this one and this one. That's why we're gonna consider this ramp as well as this section as one piece, while this section is a different area, and this section also is going to be treated differently. Now this is an example for airfield sections. As you can see, this is a typical runway with a width of 150 feet, and the taxiway would be parallel to it. And the question is, how can I subdivide even the runway? Typically, traffic is really heavy in the middle 50, this one here in the middle 50 feet, because most of the hits by the tires of the airfields are gonna be within that middle 50 feet, and that's why I'm gonna treat it differently than the other sides, the right side as well as the left side. So they are gonna be treated differently. Even the maintenance and the way we deal with the health of the pavement in the midsection here is gonna be treated differently as A1, A2, A3, and C1 and C2 and C3. This is another example here of Boston Logan International Airport. This is runway 4R to 22L. As you could see, the middle 50 feet is treated differently. If we need to have some maintenance, we can do it mainly on the middle 50 feet. We can do it because it's the most frequent hitted area along the entire 150 feet, which is the total width of the runway. So again, that gives you an example here that the middle 50 feet can be treated and maintained differently than the other areas in the runway. How about here? Now let's say this is a street section, and now we need to decide whether that intersection is going to be treated as, or is going to be included under street A or street B. So let's take a look here and see. So street B has 2 lanes, while street A has 6 lanes. So from the very beginning it shows you that street A is the more busy road and it has 6 lanes. That means it has higher amount of traffic, and therefore the intersection should be considered as a separate section from street B, and it will be considered as part of street A. Another type of classifying and distinguishing different types of sections underneath the same network is the functional classification. For example, any change in the functional classification should be used as a section boundary. Let's take a look at this here. We have this street. It used to be a major arterial, and all of a sudden, once we reach certain part of the city, now it became a local street. So that change between the functional classification of from arterial to local street, this would have and establish the borderline, and this section is going to be treated differently than this one from the perspective of maintaining the section. How about the drainage and shoulders? So a change in drainage or shoulder should also be used as a section boundary. So if we have a significant change in cut versus fill topography, or the shoulder or no shoulder, this also would be one of the biggest examples to subdivide the sections. So imagine you are driving on a certain street and there was a certain amount of drainage accommodation as well as shoulders, and all of a sudden there is no shoulder on the highway or on that street. Then that would be a reason to subdivide the same street into subsections. The other criteria that can be used to divide the sections into subsections is the condition of the pavement. In fact, significant changes in pavement conditions should be considered as one of the methods to subdivide into branches. For example, if we have surface conditions such as cracking, roughness, or rutting different from one section to the other, this can trigger subdividing the section into smaller ones. So assume that you are driving on a street, let's say University Boulevard, and you were driving and the street was really good, and all of a sudden now you would see there is lots of fatigue, cracking and rutting and potholes. From the PMS perspective, once you see that significant change in pavement condition, we have to treat those 2 sections separately. So again, the golden rule here is any significant changes, make that distinction and subdivide the sections. In fact, sometimes we would do a load deflection response, which is a non-destructive testing, and this is gonna tell us if the section here is failing versus the adjacent section is in a good health, and that also would be an indicator to subdivide the strait into subsections. Some critical issues here that we need to keep in mind is defining short sections require higher implementation effort and cost. I know that I have shown you different reasons or triggers to subdivide the sections into subsections, but we need to keep in mind that we should not also subdivide every single section by very small sections. This is gonna trigger a higher cost to implement the system and lots of effort to do that as well. The section may be too small to schedule individual maintenance or rehabilitation work productivity. In fact, too long sections also may lose uniformity and create unreasonable budgeting. So I think here what I'm trying to say is you need to be aware of the both extremes. Not too many sections or not too many little sections, and in the same time you should not have a very long payment section that's gonna lose uniformity. So keep the balance in mind. So the question now would be, how about the section labeling? Let's say I came up with a full pavement street and I came up with different sections. How can I label those subsections in a good way? So alphanumeric codes are the most common way in PMS systems, either using ABC or 1, 2, 3 by different means, or a state code or a city code versus an ID number for the section or the subsection. So here let's have an example here of this network level, and as you can see, all the sections are really labeled through numbers and names. That's mainly what it is. You do not use a word, or you do not use a star or hyphen or so on and so forth. Basically you would use a combination of numbers and letters. So I'm gonna give you here a couple examples from other DOTs that I dealt with. For example, Caltrans section labeling gets every lane on every mile post. It's a different section, and basically the sample area would be 100 feet minimum. So from every lane, from every mile, they would have to sample a minimum of 100 feet, which is gonna represent that section. Another example from other DOT is Nevada DOT section labeling. The way they do it there is they have to rate every section for every mile. So one section per mile, and they are using the milepost system over there. So the area located between two mileposts, for example milepost 1 until milepost 2, it's gonna be identified by the higher milepost number. So that section is gonna have the section with the milepost number 2, for example. The rating system under Nevada DOT is really 100 feet long by 10 feet wide. This is the section area that's gonna represent every mile. So they start at the 1/10th mile past the posted mile in the field in the direction of the travel. This is the way that they would pick the section, which is again 10 by 100 to represent every milepost. So the homework, or what I really encourage you to do now, is to look for the text dot section labeling, and we will discuss this in the next lecture. So with that, we finish chapter 3 regarding PMS implementation. Thank you.